Hello, good evening. Can you hear my voice? Anyone?
Yes, sir.
Yes, okay. Yeah, so good evening, all. My name is Chakravarti Jada. So I'll be the instructor, another instructor for this control course in BS Electronic Systems program. Particularly for this control course, I'll be handling this control course along with Vasumati. So Vasumati, I think Vasumati took previous session. So what we will be doing is we will take alternative weeks. Okay, so for this whole course. So now in this week, we are going to see the week 2 content and some of the problems. Uh, there is a question. This is the first live session. No, this is second live session. So it happened last week. So every week we'll be having our live session on every Wednesday 5 to 6 p.m. every week. Okay, so mostly what we do is uh, we will try to just quickly revise that week content, whatever is there in the video lectures. Then we will solve some of the problems. Okay, so this is a live session on 1802 2026. Okay. Do you have any questions? Somebody is posting in chat box. Let me clarify them quickly. Uh, the live session will be on every Wednesday, 5 to 6 p.m. Is that clear, everyone? Any query? It should be 5 to 6 p.m. Indian time.
Hello,
Yeah.
sir. If I'm not wrong, we got the mail for last Wednesday that the session has been cancelled or postponed. So I think this is the first session.
Uh, no, this would be the second live. So last week
Yes, sir.
was Mati.
Last session was cancelled.
Last session was cancelled.
Yes, this is the first
Yes,
session.
sir. This is the first session.
No, sir. Last session was done by another
Vasumati.
ma'am. Like,
Yeah,
yeah, yeah.
Vasumati.
That's recording is also on dashboard, like live
Yeah,
session
maybe on
section.
that day live session may be cancelled, but live session, that session would be video would be available in the course videos. You can check them. Okay. So whenever if any due to any reasons, so maybe due to holidays or internet issue at our end, if we don't take the live session, so obviously we are going to record it and upload it in the course web page. Okay, so we have that Excel sheet. You will find the links. So they are freely available on YouTube. You can check at any time. Okay. So, and apart from this, you can do all the discussions on the Google chart, this space, Google space. Okay. Yeah. You can always watch the live sessions which are available on YouTube on the course space. Okay. So, this session for week 2 content, week 2 of the course. So, what we will do is I'll quickly revise what's there in the week 2, and then we will solve some of the problems since we have only 1 hour time. Okay, so every time I suggest you to watch the videos and come so that we'll have enough time for discussing more problems. Okay, so in week 2 lecture 1. Okay, so week 2 lecture 1 mostly so it is about different signals in the controls, different signals in the control. So as part of that, so we basically have the professor has basically discussed what is open loop control system, So open loop system. Then he has also discussed specifically the closed loop control systems. Okay, where specifically we use the feedback mechanism. Okay, so then various signals in this closed loop system. Then followed by that, so various systems in systems in this we handle in these control aspects particularly. So what are stable systems and unstable systems? Okay, so I'm just revising what we have in the week 2 content. Okay, and so he also has discussed various signals. Okay, so we use particularly during the this course. So some of them are analog versus digital. Okay, then we have continuous and discrete. So all these concepts you might have saw in the signals and systems course. Then we have deterministic and non-deterministic. Okay, so then we have even signals and odd signals. Okay, then we have periodic and aperiodic. So these are basic concepts in the lecture 1 where Sarah has discussed. Then in the lecture 2, so I guess almost of all these concepts have discussed and you might have gone through your signals and systems course. So here we are, you are specifically expected to know what is open loop system and what is closed loop system, where we specifically introduce the mechanism of the feedback. Okay. Then so in the lecture 2 specifically, he has discussed what is this convolution integral. Convolution integral, the difference between time domain versus frequency domain. Okay, then so converting from the then he has discussed various basic signals. So such as impulse, step function, step signals. So impulse is delta of t, step is u of t, then ramp signal. Okay, so consider this is just the revision or recap of the lecture content. Okay, so then he has discussed so the convolution part. Okay, so this is the content of this lecture 2. Okay, next in the lecture 3, so in the lecture 3, so Sarah has discussed particularly Laplace transforms. Okay, so which we convert from, which we go from the time domain to so frequency domain and frequency domain to a time domain. Okay, so we saw the definition of the Laplace transforms. So definition of Laplace transforms, then some of the properties of Laplace transforms, then finding Laplace transforms for standard signals, standard signals like impulse, unit step, and ramp, and sinusoidal signals. Then we also saw the inverse Laplace transforms, then application of the Laplace transforms, application of Laplace transforms to differential equations, ordinary differential equations. So that's one more topic we saw. Then, so these are the major topics we saw in lecture 3 and lecture 4. Okay. Are there any queries in this? I'm sure you have gone through all the videos. Okay. So in this week content. Okay. So we'll solve some of the problems related to the Laplace transforms here in this class. Okay. So let's start the problems. So if you are having any doubt at any point of time, if you don't understand something, you can always ask me directly. Okay. So first, so find Laplace transform, okay, of f of t equal to t e power minus t u of t. Okay. So that is the question. So first let us look for the definition of the Laplace transforms. Laplace transform of f of t equal to f of s, which is nothing but integral 0 to infinity f of t e power minus st dt. Okay, where we also define its region of convergence as RE of s is greater than 0. So this is the definition of the Laplace transform. Okay, so we also call that is as unilateral definition. Okay, so we also see the bilateral definition. Okay, first what we do is, given f of t, we have to find the f of s. Okay, so let's start with that. F of s is equivalent to integral 0 to infinity. So t e power minus t u of t. So e power minus st dt. So we are just substituting the f of t function here. Okay. So now I can write this as integral 0 to infinity. So t e power minus s of s plus 1 t dt. So combining this exponential term here and here. Okay. So here you have two terms, u and you have two terms, sorry, you have two terms. So one term and this is second term. Okay. In generally in integrations, we know that we call that is as u, this is v. Okay. We know that integral uv formula as u integral v minus integral of u dash integral v. Okay. So this we apply. Okay. So once you start applying, you will get like, so first one is so here, so u t integral v, so that is e power minus of s plus 1 t by minus of s plus 1 t. So integral 0 to infinity minus integral 0 to infinity u dash. So t dash is 1. Then again integral of v e power minus of s plus 1 t by minus of s plus 1 dt. Okay, so I hope there are no doubts. Okay, so we can write this now as, so first part, once you substitute infinity here, so that will become 0. E power minus infinity is 0, minus when you substitute 0 in place of t, you'll get 0. Okay, so plus, because minus into minus plus, by s plus 1. Okay, so the other one is, so this one, so that is integral 0 to infinity. So e power minus s plus 1 t. So that would be like again e power minus s of minus of s plus 1 t by s plus 1. Okay, So in that, if you write it, okay, so you'll get, when you substitute again in infinity, you'll get 0. Then when you substitute t is equal to 0, you'll get 1. Okay, so that will be like 1 by minus of s plus 1. Okay, I hope this should be clear. If you're having any doubts, you can ask me. So we are just substituting the u and v terms and then take the integration. Okay, so finally we get like 1 by s plus 1 whole square. Okay, so that is the Laplace transform of t e power minus t u of t equal to 1 by s plus 1 whole square. Okay, so this is the final. Okay, are there any queries in this? Okay, so now we have to find, not just finding Laplace transform, we have to find the ROC also, region of convergence. Okay, so basically region of convergence means, so I'll go to the next page. So region of convergence means we have Laplace transform of f of t equal to f of s. Okay, so that is 0 to infinity f of t e power minus st dt. Okay, in this s is nothing but a complex variable sigma plus j omega. Okay, so now, so region of convergence means in a region where this the Laplace transform is possible. It means that, so for this to find the Laplace transform, so the integration must be a finite value. So that means, so to find ROC, okay, so the integration, that is nothing but minus infinity to plus infinity. Okay, so the f of t, once you substitute s is equal to sigma plus j omega. Okay, so you will get e power minus sigma t real part. Okay, multiply dt should be infinity. Okay, so this is what the condition for the Laplace transform to be existed for this f of t. Okay, so to find the ROC, we use this condition. Okay, so now for this given problem, so f of t is given to us, so substitute into this equation. So minus infinity to plus infinity. So f of t is t e power minus t e power minus sigma t, so dt. Okay, so that is nothing but, so minus infinity to plus t e power minus sigma plus 1t dt. Okay, so the condition is, so this dt must be less than infinity. Okay, so now if you see this, to make this entire integral to be less than infinity, okay, so the sigma plus 1, that must be greater than 0. Okay, so it means that, so the sigma must be greater than minus 1. So it means that sigma is nothing but what? The real part of s, that must be greater than minus 1. So here the ROC is nothing but the real part of s must be greater than minus 1. So this is the ROC for this given problem, that is nothing but, so the real part of s must be greater than minus 1 for that region only. So the uh, Laplace transform would exist. It means that if this is the s plane, okay, so this is sigma, this is j omega, okay, minus 1 is somewhere here. Okay, so always this has to be, so the Laplace transform would exist in this region only. Okay, so any queries here? So finding Laplace transform for the given function. okay, using the basic definition of Laplace transform and finding its region of convergence. Okay, any queries?
Yes, sir. Could you please explain the ROC again?
Yeah, so ROC is nothing but the region where this Laplace transform would exist. Okay, so the condition here is this is the definition. Okay, this is the definition. So for the function f of t the Laplace transform to exist, this integral f of t e power minus sigma t modulus should be a finite value. Okay, so that means if you take the integration from minus infinity to plus infinity for this entire function f of t e power minus sigma t, that should be finite. Okay, so we are using that condition to deduce this final condition. So that is the region of convergence. Okay, so
Yes, sir.
yeah, so this is using the basic definition of finding the Laplace transforms. Now we will see, as I said, Laplace transform, we have properties also where we can use the properties and find the Laplace transform easily. Let us do one more problem. Okay, so here let us say f of t equal to, so t e power minus t u of t minus capital T. Okay, so this is my f of t. Now I have to use the properties of Laplace transform to find the Laplace transform for this f of t. Okay, so now if you see here, so I'm writing the properties which I'm going to use. Okay, so first one. Okay, so first one is Laplace transform of f of t minus capital T u of t minus, sorry, f of t minus t naught u of t minus t naught, which we call this is as a time shifting property. So the Laplace transform would be minus s t naught f of s. Okay, where f of s is the Laplace transform of f of t. So that means f of t Laplace transform is capital f of s. So I'll write like this, both directions. So left to right is Laplace transform and right to left is inverse transform. This first property is the time shifting property. Why? Because here we have this u t minus capital T. Okay. So second thing is, since I can see that this f of t has e power at term. Okay, so I can write e power at multiplied f of t. So Laplace transform is capital F of s minus a. Okay, so third one is, again I can see that we are multiplying with small t. So I would also take that property t f of t. We call this is as a multiplication property, multiplication with the t property. So that would be like minus d by ds f of s. So we use these three properties. We are selecting these three properties based upon the form of the f of t. Okay, so first one is time shifting, second one is exponential property, third one is the multiplication with the t. Okay, so now let's start with that. Okay, first I'll try to write down f of t in this fashion. So f of t as t e power minus t u of t minus t as, so let's say we write it like a t e power minus t minus capital T. So e power minus t u of t minus capital T. So I'm multiplying and dividing with e power minus t, so that I'll have some clarity on using the first property. So I can write it like e power minus t. Okay, so t e power minus of t minus capital T u of capital T. Now you can see this. Okay, so I'll call this one as f1 of t. Okay, now you can see this f1 of t I can write this function as now e power minus capital T. Okay, let's say T. Okay, f1 of T. T f1 of T. Now again I'll call this one as f2 of T. F2 of T. So finally, what is my equation here? F of T equal to what? E power minus T f2 of T. I hope it is clear. Okay. Now if I take the Laplace transform, what is my Laplace transform here? F of S, because Laplace transform of f of t is f of s. Okay. E power minus t, minus capital T is a constant, e power minus t is also a constant. So e power minus t. Okay. So f of 2, f2 of t Laplace transform is f2 of s. Okay. So this is my Laplace transform. Okay. Now if I simply find the f2 of s, multiply that one with e power minus t is my f of s. Okay. So let's call this is as equation 1. Is there any doubt till this point? Any doubt? Okay. So now let us start with the finding capital F2 of S. Okay. So capital F2 of S is nothing but Laplace transform of F2 of T. That is nothing but Laplace transform of, so F2 of T is nothing but T F1 of T. T F1 of T. Now you can go and check the properties. What is the Laplace transform of T F1 of T? It's going to be minus d by ds of f1 of s. Okay, so minus d by ds of f1 of s. Okay, so let's call this is as equation 2. Okay, now from the equation 2, if I simply find the f1 of s, which is nothing but Laplace transform of f1 of t, which is nothing but Laplace transform of f1 of t is nothing but what? So this term. Okay, so that is e power minus t minus capital T u of t minus capital T. Okay, so now you see this one Laplace transform of how does it look like? It looks like the first property. What is the first property here? So this one. So first property is f of t minus t naught u t minus t naught. Okay, so that is nothing but e power minus s t naught f of s. Okay, so that is nothing but e power minus s t naught is capital T multiplied f of s. Here f of s is nothing but what? E power minus t. That is nothing but 1 by s plus 1. I hope it is clear. Okay, so now this is your f1 of s. Now from 2 we can write f2 of s is nothing but minus d by ds of, so e power minus st 1 by s plus 1. Okay, so this is the thing. So now how does this one looks like? Minus d by ds of e power minus st by s plus 1. Okay, so you have to take the derivative with respect to the s. So again, so we can borrow this from the calculus. That looks like u by v derivative. Okay, so that's like u dash v minus u v dash divided by v square. Okay, so I can use that now. So I can find it like f2 of s as minus of, so let's say this is u, this is u, this is v. Okay, so I can write it like minus t e power minus st s plus 1 minus e power minus st 1 divided by s plus 1 whole square. Okay, I think this should be clear to everyone. Okay, so I can write it like I can take the e power minus st common outside. Okay, so it will be like t multiplied s plus 1 minus 1. So divide by s plus 1 whole square. So that is my f2 of s. Okay, so once we have f2 of s, I can directly substitute here to get f of s. Okay, so now using equation 1, I can write like f of s equivalent to e power minus t f2 of s. Okay, so that is nothing but e power minus t. So f2 of s is what? E power minus st. Okay, so this is t s plus 1 minus 1, that is f2 of s by s plus 1 whole square. Okay, this is my final f of s. Is this clear? Any queries? So what we are trying to doing is first by seeing the f of t. Okay, since this has this u of t minus t, so I'm taking the help of the time shifting property. Then we are multiplying with e power minus t. Then I am taking the e power at f of t property. So then t e power minus t, sorry, multiplying with t f of t minus d by ds of f of s. Okay, so systematically we can find the Laplace transform uh, using the properties. Whereas in the first case, directly we have used the basic equation. Okay, so basic equation of Laplace transform. Whereas in the second case, we have used the properties. So there is this small difference between signals and systems and control systems, wherein signals and systems is basically deal with all signals and systems, particularly in Laplace transform, Fourier transform. So highly analytical course. Whereas control systems is very restricted to some of the signals. Okay, so that's why we don't use the basic definition to derive all the things. Instead, we mostly use the properties while we solve the problems. Okay, is there any doubt here in this problem? Are there any doubts? If you're having any doubts, if there are no doubts, we'll move to the next problem. Okay, so next problem is finding the response. Okay, so okay, here we have impulse response. Impulse response of causal LTI system. Okay, causal LTI system is impulse response is h of s equal to s plus 1 divided by so s square plus 2s plus 2. Okay, so this is the response. Okay, so the question is determine y of t. Okay, so when input x of t is so e power minus mod t, where t is between minus infinity to plus infinity. Okay, so this is the question. So let's check one by one and go ahead. So basically what we have is we have a system. Okay, so we have a system which impulse response is h of t, and it has input of x of t, output of y of t. Okay, so generally if you see the convolution concept, So we get y of t as convolution of x of t with h of t. Okay, so once you take the Laplace transform, okay, so you go and check the video for this convolution equation. Okay, once you take Laplace transform, apply Laplace transform on both these sides. Okay, so you will get like y of s is equivalent to x of s h of s, x of s and h of s. It means that in time domain, okay, so two signals x and h, they are convoluted, means in frequency domain they will be multiplied. They will be multiplied. So now if you take the inverse Laplace transform, so we get its y of t, that is nothing but Laplace inverse of y of s, that is nothing but Laplace inverse of x of s h of s. So is this clear? Any doubt in this? Because this is the base thing to solve the above given problem. Okay, so in general, so any system, any LTI system, okay, system response is nothing but this h of t, which is also nothing but the impulse response. Okay, so that is given to us. Okay, h of t, h of s is given to us. That means impulse response, so in time in frequency domain is given. Okay, so input is x of t and output is y of t. So here once we know this h of t, we are giving a input of x of t is equal to e power minus mod t. Okay, once we give that, the question is what is the y of t expression? What is the y of t expression? Okay, so from here you could write what is h of s. H of s would be equivalent to y of s by x of s. That also you can say that. Okay, so now let us proceed. Okay, so let's start with this x of t expression. Are there any doubts in this page? Are there any doubts in this page?
No, sir.
Okay, yeah. So now let's start with the input signal x of t. Okay, so x of t, what do we have? X of t is e power minus mod t minus infinity less than t is less than infinity. Okay, so what is mod t basically? Mod t is like, so it will be t when t is greater than 0. It will be minus t when t is less than 0. I hope everyone knows this definition of
Yes, sir.
mod t. Yeah, so now if you from this you can write e power minus mod t. Okay, so that will be like e power minus t, okay, for t greater than 0, e power plus t for t less than 0. That's what I can write. So from here I can write this one as 0 less than t is less than infinity. Whereas from here I can write minus infinity less than t is less than 0. Is this also clear? We can write it in this way. Okay, so now what we have is x of t, that is nothing but e power minus mod t. So this I can write it is write with the two things, summation of both this one as well as this one. So the first one as well as second one. Okay, that would be like e power t. Okay, so u of minus t plus e power minus t u of t. Okay, so I'm sure. So we are adding the second part, that is from minus infinity to 0, and we are adding the first part 0 to infinity. So second part plus first part. Okay, so if you plot it, this is t, this is x of t, that is summation of two signals. Okay, so this will be 1. Okay, so first one is this, which is nothing but e power t u of minus t. Okay, so the second one is this e power minus t u of t. Okay, so here we have minus infinity. This is plus infinity. I hope this is clear. Okay, so now you see that signal having two sides. So one side is from minus infinity to 0, second side is 0 to infinity. So now what we do is we take the help of two-sided Laplace transform. Right? Previously in the first problem we saw only the one-sided Laplace transform. Here we take two-sided Laplace transform, which is nothing but minus infinity to plus infinity. Whereas in the first problem we took 0 to infinity, which is nothing but the unilateral Laplace transform. Here this is bilateral or two-sided. So the rest of the terms are same. So e power minus st dt. Is this clear? So this is a two-sided Laplace transform. Okay, so now
Yes,
if you substitute the terms, so it will be like minus infinity to 0. So e power t u of minus t e power minus st dt plus integral 0 to infinity e power minus t u of t e power minus st dt. Okay, so these things you can directly write and count them. So first part, let me write it. Let me take this one there. Okay. Yeah. Okay, so the first part I can write it like minus infinity to 0 e power 1 minus s t dt. Okay, so plus integral 0 to infinity, because u of minus t is 1. So e power minus of 1 plus s t dt. Okay, so first one is nothing but e power 1 minus s t by 1 minus s minus infinity to 0, plus second part is e power minus of 1 plus s t by 1 plus s. Okay, so 0 to infinity. Okay, so first one, if you write 1 by 1 minus s, if you substitute minus infinity. Okay, so when you substitute 0, you'll get 0. When you substitute minus infinity, you'll get 0. When you substitute 0, you'll get 1 by 1 minus s plus 0 1 by minus of 1 plus s. Okay, so if you simplify them, finally you will get 2 by 1 minus s square. 2 by 1 minus s square. I hope this is clear. This is nothing but x of s. 2 by 1 minus s square. Okay, so now go back to our equation and take the help of, now we got our x of s, you know already h of s. So we just need to find y of s and take the inverse Laplace to get this y of t. That is our intention. Okay, so let's take that. So we have y of s equivalent to h of s x of s. So h of s is s plus 1 by s square plus 2s plus 2 multiplied this one is 1 by s minus square. Okay, so this can be written as 1 minus s 1 plus s. Okay, so we can strike out these two. So we get, so we get the here we have 1 minus s, so I take minus out, it will become minus 2. So s minus 1 s square plus 2s plus 2 this is nothing but y of s. Okay. Now our job is to find y of t. Okay. So before finding that, we use the partial fractions. So okay, so do the partial fraction expansion. So take the partial fraction expansion. So what you get is a by s minus 1 plus, so this side I can write, so s minus 1 s squared plus 2s plus 2. Here this will be like bs plus c by s squared plus 2s plus 2. I hope this is clear to everyone. Okay, so I can write here as s minus 1 s squared plus 2s plus 2. This will be like a multiplied s squared plus 2s plus 2 plus bs plus c multiplied s minus 1. Okay, so these are the two things. So this side we have minus 2 and this side we have this numerator. Okay, so what you can do is, so you can compare the coefficients. Compare the coefficients on both numerators, because denominators are same. Okay, once you compare the coefficients, so you will get like both sides, and I'm leaving that one to you as an exercise. So you'll get the ABC values. A will be like minus 2 by 5, B will be 2 by 5, C is 6 by 5. I hope you can do that part, comparing the coefficients on both the sides. So you'll get A, B, C. These are the values you should get. Now, once we have this A, B, C, y of s we can write as, so y of s is equivalent to 2 minus 2 by 5 s minus 1 plus b is 2 by 5, c is 6 by 5. So divide by s square plus 2s plus 2. Okay, so this is the first step. Is this clear? Any doubt?
So far, no, sir.
Yeah. So now we have to take the inverse Laplace for this. Okay, we have to take the inverse Laplace. Again, we use the standard Laplace transforms to take the inverse Laplace. So there comes the trick. What we do is we try to do something in the reverse way. Okay, so we know already that Laplace transform of e power at, which is nothing but 1 by s minus a. Okay, there is no issue here. Okay, so then Laplace transform of we have Laplace transform of sin at, okay, which is nothing but a by s square plus a square. Am I correct? Right, Laplace transform of sin at. Okay, so what about Laplace transform of cos at? That will be s by s square plus a square. Is this correct? Okay,
Yes,
now,
sir, this is right.
yeah, so now combining these two, Laplace transform of e power bt, okay, e power, let's say, minus bt sin at. Okay, so if you use the properties, this would come like a by s plus b whole square plus a square. Similarly, Laplace transform of e power minus bt cos at will be like s plus b by s plus b whole square plus a square. Now I suggest you to observe all these three expressions, okay, with the denominators of this one and this one. What do you observe? Okay, in first thing is that is s minus 1, which we can directly say that is related to this. Am I correct? Yes.
Yes, sir.
So
Yes, sir.
yeah, so second denominator So this denominator is something like s square plus 2s plus 2. Okay, it is like a plus b whole square plus something square. Okay, so that is related, something related to this, correct? Okay, in the numerator, if you see, you have s term, here you have s term, you have constant term, you have constant term. It means that somehow we have to use these three Laplace transforms, okay, to find the y of t expression. It means that we go in the reverse way. In the reverse way means, so the first term is giving an indication that is related to this expression. The second term is giving an indication that will be the output for these two. Is that clear? So some sense. Okay, now what we do is, so I'll write it properly. So y of s. Okay, so first one is minus 2 by 5 1 by s minus 1. Okay, so that directly says that Laplace transform is e power at, that is e power sorry, this will be minus 1, that will be e power t. Okay, there is no issue. Okay, second one, if you see, how can I write this one in terms of a plus b whole square? I can write this one as s plus 1 whole square. What is that expression? S square plus 2s plus 1, correct? So, but here we have 2. So I can add one more term. Okay, and I can put square here. Is that correct?
Yes, sir. Simply by
Yes.
completing square.
Yeah. So now you can compare this expression with the denominators of these two. Okay, so that's now you can able to find a is equal to b, a is equal to 1, and b is equal to 1, correct?
Yes, sir.
Yes. So now there is no problem with the denominator. So now numerators we have to make the proper comparison. Okay, so now I'll write it like this. So I'll write this one as 2 by 5. Okay, so first term I'm separating it, this term. So that will be like s plus 1 whole square plus 1 square plus 6 by 5. So I'm writing like x plus 1 whole square plus 1 square, correct? Now here, what do we have? We have s, correct? So what I do is, I'll put s, okay? Once we have s, that is belongs to what? This term, correct? So I need to have b here. So what is b here in this expression? 1. Am I correct? Since I have added plus 1, I'll take minus 1. Is this correct?
Yes, sir.
Yes. So next here 6 by 5, I'll keep 1 here because a is 1. Now you can see this. You can see this term. How does that look like? It looks like this term, correct?
Yes, sir. With a
Yeah.
equal to 1.
Yes. Now here you can see this whole term. How does that looks like? That I can write it into two parts. One with this part, which will be equivalent to this, correct?
Yes, sir.
It will be equivalent to this. Another with only this part, it will be equivalent to this. Am I correct?
Yes, sir.
Yeah, so now I'll write it like minus 2 by 5, 1 by s minus 1 plus 2 by 5. Okay, so s plus 1 by s plus 1 whole square plus 1 square minus, okay, so 1 by s plus 1 whole square plus 1 square, just separating those terms, plus 6 by 5. So 1 by s plus 1 whole square plus 1 square. Is this clear? Any queries? Now you can see.
Yes, sir. Clear.
So yeah, you can sense that. Now directly, I don't want to go to the next page. So directly write the output here. So directly y of t as Laplace inverse of y of s. Okay, so which is nothing but minus 2 by 5. 1 by s minus 1. That means that is what? E power t. Yes. Okay. E power t. Okay. Plus 2 by 5. So this will be s plus 1 by s plus 1 whole square plus 1 square. So I can write that one as e power minus t. Okay.
Cos AT.
Cos
Cos
t.
T. Yes, sir.
Yes. Minus e power minus t sin t plus 6 by 5 e power minus t sin t.
Sin T.
Okay. This is the final expression. Okay. So the core part here is using these equations properly. Okay. Is there any doubt here in this anywhere? If you don't understand or any query?
So the 2 by 5 part will be multiplied to the whole expression.
Which one? Yeah. Correct. Here, 2 by 5. This should be like 2 by 5. Here also we have. Yeah. Any queries? So this is how you can find the Laplace transforms, particularly by using the properties. Okay. So mostly we use the properties to find the Laplace transforms. Okay. So I think time up. So we'll stop here. I'll upload this notes also in the space immediately, and I'll also upload this video as well. So you can go through that video and you can ask the doubts. Okay. So thank you.
Excuse me, sir.
Yeah.
Do we have surprise quizzes for controllers also?
Surprise questions.
Surprise quizzes?
Surprise quizzes mostly no.
Mostly no.
We have as per the schedule only, but I'll let you know. I'll
Okay,
check once with Vasumati and I'll let you know because course has just started. I'll check.
Because other subjects have surprise quizzes. Like yesterday we had sensors. So do we have something similar for control engineering also?
Okay. I'm not sure, but I'll check with Vasumati and I'll let you know.
Sure, sir.
Yes, the same was the case for analog as well.
Okay.